Cisco Certified Network Associate Day 38. Welcome back everyone, I'm Imran Rafai, your trainer for this entire series. Today we're going to do layer 2 EtherChannel. We would be not getting into layer 3 EtherChannel, even though layer 2 and layer 3 is not very different, but I need to introduce few more concepts before I come into layer 3 EtherChannel. So we'll come back to layer 3 EtherChannel when the time is right, but today we're going to do layer 2 EtherChannel. And I must apologize for my voice. I'm not feeling too well, so my voice is not the best. I promise you today's video is not going to be as long as the last video, so it is going to be a much shorter video, and it should be fun, right? So without wasting much time, let's get straight into today's class. On the left you see our company's social media contacts like Networking Consultant and Networking Inc. On the right, Imran Rafai. Those are the three contacts for Facebook, LinkedIn and Twitter on the right? And my email address, imran.rafai@nwking.org. That's for anything that you need to contact me for, right? Like I said, going by the Cisco's ICND exam topics, we see 1.5 is what we will be covering today, but 1.5 also says layer 3. We will not be getting into layer 3. So configure, verify and troubleshoot layer 2 EtherChannel, and we have three types: static EtherChannel, PAgP protocol EtherChannel, and LACP protocol EtherChannel. We will look what these are. We will understand a little bit more about these and the differences, right? Before we go ahead, we need to understand what is an EtherChannel. So let's assume we have switch A and switch B, and let's assume we have two redundant links between these two switches, or even if you want, we could give three redundant links. Knowing what we know so far, the minute we put three redundant links between A and B switches, STP would kick in. STP would do what it has to do, and all but one link will get blocked in either side, depending on the STP algorithms and all that we learned in the last video. So depending on that, two of these three links would get logically blocked off, right? So let's assume these links are fast Ethernets, right? Or like, let's say they're 100 Mbps lines. So no matter, in spite of having 3 into 100 Mbps, which could have been a technically 300 Mbps line, or at least the bandwidth, we are blocking two of them and using only one. So that's a challenge. That's a challenge with STP, where the bandwidth is going to go down. So to prevent this STP and not using the entire bandwidth, a company called Kalpana, if you remember Kalpana was the company that invented the Cisco Catalyst switches, which Cisco eventually bought from Kalpana, right? So in the 1990s, this inventted the technology called EtherChannel, right? So like I said, what EtherChannel does is EtherChannel combines these three links, and they make it into one logical link, of 300 Mbps. That's all what EtherChannel does. Now there are three types of EtherChannels. You could have the static version. Static version says you say EtherChannel on, and EtherChannel on, and EtherChannel will come up. It will not look at any parameters. It will not check if the parameters are matching. It will not check if the correct configurations are there. Just a statically on state, right? So the EtherChannel is on. That's one way, static way. Or we could use two protocols. We could use the Port Aggregation Protocol. This is a Cisco proprietary protocol. Or we could use Link Aggregation Control Protocol, which is an IEEE standard, right? So these are the three types of EtherChannel that we can enable. Now, how do we enable these? EtherChannel enabling, the static version, is very, very easy. You go to the interface, whichever interface that you need. So let's say you have a switch, and we have FA0/1 port, and we have FA0/2 port, right? This is switch A. Now we have to go into each of these ports and give the same command. So we say channel group, and we need to give a channel group number. This channel group number is a number between 1 and 6, right? And then we give the keyword mode, and we say on FA0/1. Again, we go to FA0/2. We would do the same thing, channel group 1 mode on. So basically, if you want to club these two, this number should match on both the ports, and everything else also should match. So if at all one of these ports is an access port, the other one has to be an access port. If it's a trunk, then both of them have to be trunk. If it's a trunk, then even the native VLANs should match, right? So a lot of aspects should match, and that is only when that happens they would form a port channel, right? So it become a group channel group, which is nothing but, again, another thing that I need to say, EtherChannel, port channel, channel group, these are all referring to EtherChannel. So we will see how it differs, but most of them, for all practical purpose for CCNA, all these three things, channel group, port channel, and EtherChannel, they all refer to EtherChannel, right? So this number is critical. This is locally significant to the switch, right? Let's say if there is another switch here, and these are connected here. So let's say this is 0, 1 here, and this is 0/2, and here again on this side of the switch, both these interfaces should have channel group, and on this side it can be anything you want. You can give channel group 1 here, doesn't matter, because that is locally significant to the switch. So we can say local channel group 2 mode on, again that'll work. But the channel group number can change, but everything else has to be the same. So like I said, if this is the trunk and this is a trunk, both of them should have the same native VLAN. If it's an access point, then both of them should be access points. Technically it will not be an access point between two switches, but again, the concepts that you will understand a little while later. But for the moment, just understand that both the interfaces, or all the interfaces that is part of the channel group, should have the same major settings, right? So once you do that, you go into both these interfaces here and give this command, go to both these interfaces here and give this command, EtherChannel will get formed, right? So for all practical purpose, after that EtherChannel is formed, these two interfaces, physical interfaces, will act like one interface. So if you go to even spanning tree and check spanning tree is going to treat this as one interface from that point on. So once EtherChannel comes up, this interface is clubbed and treated like one interface. So that's what it is. So that's what EtherChannel does. EtherChannel makes a group of interface into one single logical interface, which is much faster than the individual interfaces, right? The next thing that we will look at is PAgP, right? PAgP is, again, like I said, is a proprietary Cisco protocol. It is port aggregation protocol. So now let's assume the same case. We have a switch here. We have two ports, 0, 1, 0, 2. We have another switch here, two ports, 0, 1 and 0, 2. So once that's done, again the same thing, everything needs to match. But now each of these interfaces, you would go and say channel group, the same thing, you could give a channel group number from 1 to 6, mode, and we use the keyword desirable or auto, right? So if you're doing static, you have to give on both sides, and that forms. But in PAgP, you have this option either to put desirable or auto. So basically, when you come to channel group 1 mode, and then if you hit question mark, you would have 5 options. You'd have option on, desirable, auto, and then two more commands, that is active and passive, which is for LACP, right? So just by choosing this, it automatically chooses the protocol that you're going to use. So let's say you use desirable. So one side you use, say, desirable. This, let's say, is one side and the other side. So if you use one side desirable and the other side desirable, the port channel will come on. If you use one side auto, the other side desirable, port channel will come on. If you say desirable and auto, port channel will come back. But if you say auto and auto, the port channel will not come on. So the only thing that you need to remember is, if you want a port channel to come up in PAgP, one of the side will have to be desirable, right? So if there is a desirable on either side, the port channel will come on. If both of them are auto, or if desirable is not there on either side, it will not form ether channel. That is how you get PAgP protocol enabled and an ether channel formed, right? Next, the same way, two switches A and B. If one side you like I said, if you look at the command is the same. Channel group, you give a local number and say active or passive. If you say active on one side and other side active, it becomes ether channel. You say passive and the other side active, you form an ether channel. Active and passive, it would still form an ether channel, but passive and passive, it will not form an ether channel, right? So again, here what you need to understand is one of the side will have to be active to form ether channel in LACP. Now, can you use one side? Let's say you have switch A and switch B, and you have two links, right? And you have two links. Can you use active here and auto here, or desirable here? Well, absolutely not. If you have active here, it has to be either active or passive on the other side. That's when it will form LACP link. If you have active and if you have auto or desirable, which is a PAgP one, it will not form ether channel, because LACP and PAgP are not interoperable, so they cannot talk to each other. So that will not form ether channel. Some of the commands that you need to do, like I said, your channel group number can be anything. So even though it says 1 here, it technically means you can put any number there. Mode, and then you put the option. Like I said, the options here are on, active, passive, or desirable, auto, right? One of the 5 options that you need to choose from here. So in sub interface command, we're using the keyword channel group. But let's say, for instance, you want to do load balancing, right? Load balancing is something. So let's say we have, let's say again, switch A, right? Switch A has 2 ports, and this is switch B, and let's say switch B has 3 PCs, PC1, PC2, PC3 connected. And let's say there is a PC 4 here, right? So we would think that if traffic is going from PC4 to PC1, this switch would start sending traffic on both the links. One packet there, one packet here, one packet there. Well, not really. Load balancing does not really happen that way. In ether channel, load balancing happens different modes. By default, Cisco switches do source MAC address. So let's say they have a hashing algorithm. So after doing the hashing algorithm, decides one of the ports. So let's say, for instance, the hashing algorithm it does with the source MAC address. So from PC4 source MAC address, it does a hashing algorithm, and let's say it decides that traffic would all traffic from PC4 would go on this link. Then all traffic, immaterial of whether it's going to 1, 2, or 3, will only go through this. Let's say there was a PC5, and if PC5, after doing the hashing algorithm, it decides that PC5 traffic will always go on this, it will always go on this link, right? But then it is not ideal situation, right? So for instance, if let's say there is internet, and this is a device, and let's say there's a switch here, and the switch is connected to 3 it's connected to 3 PCs. Now all traffic, if if traffic coming from outside the network, will all come with the source MAC address of this particular device or this particular port, because this is the gateway, right? So this is the gateway, so all traffic will have a source MAC address of this guy. Now let's say, for instance, there was another switch here, right? I'm just gonna simplify it for you. If there was a switch here, can this switch, because all the source MAC address is going to be the same immaterial of where it's coming from, it will always decide to send through one of those interfaces. So that doesn't really serve the purpose. It has to be different. So that's why we have a chance to go and change the parameter with which the switch does the load balancing. So you can go to the global config and say port channel load balance, and you can choose load balance option. We could, in this case, we can say destination MAC address. So depending on the traffic, if at all this traffic is going to let's say switch 1, send traffic here. If it's going to PC3, send traffic here. If it is PC2, send traffic here, right? So that's something that you can change. So how do you change that? Port channel is the keyword that we use. So global config port channel if you're doing load balancing, interface command you do channel group if you want to set the mode, and if you want to do show command, you say in the privilege mode, you say show EtherChannel. So the keyword here is EtherChannel, and we say summary. If you do EtherChannel summary, it will tell you the EtherChannel and which are the links that's being used and the protocol that's being used. If you want to know what option it is using for load balancing, you can say show EtherChannel load balance, and it will tell you what is the current load balancing technique that it is using. Right, so let's look at this from Packet Tracer. Alright, so we have two switches and I take two links, and like you know, as soon as I connect these two links, STP would start doing what it does, and one of the ports will get blocked. Right now, that's not the ideal situation. We want to use both these links like we discussed, so that we have a much higher bandwidth instead of using one of those physical links. So now we see that STP has done what it has to do, and one of the link has gone into blocking state. So let's do this. Let us go in here, right, and say show spanning tree, and then we see that spanning tree is running, and root ID, bridge ID, and then FA0/2. So let's just yeah, slightly more so that we can see what it does. Okay, so we'll look at spanning tree here as well. Show spanning tree, and we see that this device has become the root, and FA0/1 in designated, and in here one is alternative port with nothing but a blocking port, and then we have root port. So this is fantastic. So STP has done what it has to do, and we know why it did what it did. So let's start with doing Cisco's proprietary PAgP. So how do we do PAgP? We go in here. We could let's say interface F0/1 and then say channel group, and we can give a number. So you can say channel group 1 to 6. So I say 1, and I say mode, and like I said, these are the 5 options: active, auto, desirable, on, or passive. So these are the 5 options that's available. Since we're doing Cisco proprietary PAgP, I would say desirable, and I hit enter. You would see that the line protocol went down, and then line protocol came up, right? So basically it just changed the it just associated it with port channel called 1. So it created a port channel, creating port channel interface port channel 1, and then it the protocol went up and came down. So let's do interface F0/2, and we can say same thing. We can say channel group 1 mode desirable, right? So here it can't be desirable auto because this is in switch. In one switch, all the ports should have the exact same command. The auto part can be on the other switch, right? So this switch, you can either choose it to be desirable, or you can choose it to be auto. But in this switch, all the ports should be the exact same thing. So we need to go and give channel group 1 and then say mode desirable. Right, this is one way to do it. We could also do something called the range command. So we can go into config T, interface range F0/1 and 2. So if you have, let's say, 10 links, you don't have to manually go into each of those 10 links and do the mode command. We can do a range F0/1 to 10, whatever that you want. In our case, it's 2. So I say take this range, and I say channel group. And again, here, this channel group number, port channel can be the same number. I can give 1 or I can give any other number. So just to prove a point, I'm going to give 2 and say mode. And here, like this side, since the other side is doing desirable, this side has to do either auto or desirable to form a link. So let's do desirable and hit enter. You would see that a port channel with interface port channel 2 has been created. FA0/1 went down and it came up. FA0/2 changed state to down and then changed state to up, right? So then interface port channel 2 changed state to up. So once it created, after that it brought that port channel to up, right? So interface came up and then the line protocol also came up for port channel 2. That means now EtherChannel has been formed. So let's do that. Show EtherChannel summary. Now you would see that you would see these are the flags. So you have different flags. We'll look at that flag in a minute. So it says group 1. Right, so there is a group 1. Number of channels, channel groups in use is 1. So we only have port channel 1. Number of aggregator is 1. Right. So PO1 is port channel 1. SU. Now this S, capital S, says that this is a layer 2 ether channel, and U is that it is in use. The protocol is PAgP. We know that. The physical ports are FA0/1 and FA0/2, and also this is important, it says P, that means it is participating in the port channel, right? So now our ether channel, I can check the same thing here, show ether channel summary, and it's doing the exact same thing. We could look at a spanning tree, show spanning tree. Now you would see earlier spanning tree, if you looked here, you would see that spanning tree was looking at those interfaces individually, but now since it's a port channel, it is going to look at that as one logical interface, right? Even the cost has changed. Here the cost was 19, so as the speed increases, the cost will go down, and since the speed has increased, that cost has also reduced, right? Same thing here, show spanning tree, and we see that PO1 is the new interface, and it is in this root has not changed. The root is the same because that's what it is, but there's only one interface now. So it's as if one physical interface is between these two devices. Only that these are not physical interfaces, it's a logical combined port channel interface or the ether channel interface. How do we change from PAgP to LACP or any other protocol? Ideally you would come in interface range F0/1 to 2. Now here if you try giving channel group 1 mode, and for LACP it is active, but if you try giving active here, it would say the command has been rejected because this particular port is already part of a different protocol, right? So it's saying it's already enabled for a different protocol, so we can't accept this command. So FA0/1 interface is in that. So what we need to do is first come in here and say no channel group, right? We say no channel group 1, and we go ahead and you can start giving this command here saying channel group 1 mode active. But I think packet tracer there's a problem, so because it's the same port channel, even if I change, let's say for instance I've put this command, where did I put that command? Yeah, I put this command channel group 1 mode active after doing no channel group 1. So I've removed the old channel group 1 command and then I've put back this channel group 1 active command. Let's do that here as well. Configure terminal, interface range F0/01 to 2, no channel group 2 this time, and then I would say channel group mode active, right? So it says the port channel has come up. So if say line protocol interface port channel 1 is up, but show EtherChannel summary, it would say that the port channel has come up now. It has come up, but it is in PAgP protocol, which is not true because we are doing LACP now, right? So that's something that is wrong. So the workaround is you go there. I'm going to create a different port channel, right? So interface range FA0/1 to 2. I'm going to say no channel group 2 again. I'm going to do that here. Or let's do it one side, and let's see what happens on the other side, just to show you what happens. Show EtherChannel Summary, and you would see now this is still thinking it is working, but that's, I think, something it's a simulations problem. It shouldn't, because the port channel has gone down because there is no port channel on the other side at all, right? So if you try that same thing here, show EtherChannel Summary, you would see that port channel 2 is D is down, right? And the ports are not there because I have removed that command from everywhere. So that port channel is there technically, but is not being used, and there are no ports associated with that port channel. So if I want to do that here, I would say interface range F0/1 to 2, no channel group 1. I would go here and put a new channel group. So let's say I can say channel group 2 this time, and here I would say interface range F0/1 to 2, channel group this time I'll make it 1. So channel group 1, channel group 2. I've switched the channels now. So there is a new port channel 2 that's created here. There's a new port channel 1 that's created here, and now these should technically create a new port channel. So you see you have a new port channel, a new protocol LACP is working, and these are all working. Similarly on this side, show EtherChannel Summary, and you would see the new port channel is working on LACP protocol, right? So the difference between this and having always on interface, like for instance, I'm going to do another port channel, configure terminal, interface range F0/1 to 2, and I say channel group 3 mode on, right? Okay, so this will not work because obviously that thing. So I'm gonna right, interface range F0/1 to 2. I'm gonna first negate that, and then I'm going to give this command, right? Similarly here, interface range FA0/1 to 2, right? So I'm not feeling too well, so excuse me. Interface range FA0/1 to 2, and I say no channel group 1 here, and then I'm going to say channel group, let's say 3 this time, and I say mode on, right? Now show EtherChannel Summary. You would see that the EtherChannel is already up. It doesn't take the negotiation time like PAgP or LACP. It comes on quick, and this is why. So let's do that here. So EtherChannel Summary, and then we see that this is up and it is not doing any protocol, which is your sign that it is doing a static EtherChannel. Now Cisco says on high availability networks you have to use I mean, they say just forget about PAgP, just use the static one because that's much more reliable. Now how do we do load balancing? So we could look at the same thing. So we can say load balancing. We see that load balancing is happening on a source MAC address, right? Like we explained, source MAC address is default, but it's not the ideal situation in a lot of cases. If you want to change that, we need to come to the global config mode and say port channel load balance, and then we have these options. We can say destination IP address, destination MAC, source destination IP address, source destination MAC, source IP, source MAC. So what it does is it takes this information. Let's say if it says destination MAC address, it takes a destination MAC address, it does a hashing function, and then hashing function would tell it which of the ports that is part of that ether channel should be used for that. So every time the source MAC address is the same, it will use that particular interface, the physical interface, for it to send out the traffic, right? So that's what it is. So I hope we have covered everything that is required for this topic. Like I said, we will be back for layer 3 ether channel very soon. I hope this has been informative. So if there's anything, please feel free to contact us, and please like this video, and we will be back very soon. Thank you.